So let's begin. Well, my topic will be about provisioning an AWS Fargate fleet using Terraform. So a little bit about me. Well, my name is Juan Sanchez. I'm from Venezuela and I'm currently living in the Czech Republic. You probably might be wondering what a Venezuelan guy is doing in Czech Republic. We can talk about that a little bit later. I have an average 5 years of experience. I work for this company as a backend developer, but I'm also like a very DevOps enthusiast. And also I'm a solution architect associate certified by AWS. So yeah, let's begin with the components that are playing together for this presentation. So let's begin with AWS Fargate. What's AWS Fargate? Probably most of you know what is it. So first of all, it's one of the launch type of AWS ECS. Now, what's AWS ECS? It's basically, that stands for Elastic Container Service. And it's basically another Docker management service, or you can say like a orchestrator provided by AWS. And one of the cool thing about this is like you forget about master or manager node, so you can think of like, okay, my cluster will be always alive. And yeah, the idea is to only focus on containers, and sometimes often is referred by this like a serverless Docker, because there you only you need to care about the containers, and that's it. So let's compare a little bit Fargate with other platform as a service. One of the first difference with Fargate is like it enforces the use of Docker, which other platform as a service, probably the most famous one is Heroku, doesn't. You can deploy Docker to it, but it's not enforced. It's way cheaper. I will explain why. And also, since it's a AWS service, it has direct integration with other services in the AWS ecosystem. Of course, you need to play around with IAM resources and roles to make this possible, but it works pretty well. And at the end, you have more infrastructure control, and that's like quite related to the cheaper part, because you have less abstraction, so you need to you need to do more configuration. That means like, okay, you pay less. So let's talk about the second part of this, which is what is Terraform. Well, it has been mentioned like quite often in this conference, but yeah, let's recap a little bit. It's one of the, I would say, most popular infrastructure as code tools that are out there. I would say like it's quite like compared with CloudFormation. There are other infrastructure as code, but I would say like these two are the most popular. And yeah, the good thing about infrastructure as code is like you can version control, or you can have like a single source of truth of your whole infrastructure, and that's pretty great, because sometimes you can go to AWS and spin a couple of EC2 instances and then put some S3 bucket, whatever, and this is pretty simple, and it's very hard to forget about this, but when your infrastructure grows, you lose like the track of everything. So sometimes it's pretty hard like to say like, okay, what I'm being charged for $1,000, I don't know where this money is being taken from. So So it's like a very good practice to have like a single source of truth, to have like your whole infrastructure, and you know what's deployed, what is actually deployed in the provider. So since it provides like since you have a single source of truth and you can integrate with, I don't know, something like GitHub, for example, you can also have code review of not your code, but your infrastructure with your colleagues, and you can discuss about it. So it's pretty great. And if you're brave enough, you can also put it on a CI/CD. I say brave enough because it's not code, it's infrastructure, and sometimes things can go wrong. And also because Terraform, some main difference with CloudFormation is that it doesn't allow rollback. So, you need to be very careful. And one of the major difference with Terraform, with CloudFormation is like in multi-cloud. You can deploy many multi cloud providers, and not only cloud providers. You can also manage like even GitHub organization and stuff like that. And it has a cool thing which is like a reusable units, which are called modules. So sometimes you are like I mean, like something very complicated in AWS is to configure like a whole networking or something like a VPC, sorry. And yeah, sometimes you don't want to get into details. You want to go to like let's say the most common one, which is like okay, two ACs with one private subnet, one public subnet, and that's it. You don't want to go deeper. So this is pretty cool. And yeah, this is a personal opinion. The major benefit of Terraform is not that you can actually deploy Terraform, it's that you have the documentation of your whole infra. So this is very cool because, yeah, basically when you pass over the project to someone else, you basically can skip the part of like, okay, let's log into the dashboard of AWS and let's go to all the services that I am applying to this this project. So you just basically tell your colleague to, okay, go to the GitHub repository and you check the Terraform file and you will know what's inside. So what I'm talking about, like these two like components and how to provide like a Fargate fleet to using Terraform, because it's like I would say like it's pretty related to a STRB use case right now, the company I work for, because we're a consultancy agency that mostly focus on startup based on US, and we basically are trying to like do the migration to more automation, to more like, let's say, DevOps culture. So the thing is, like, for example, right now, right now, most of our projects are deployed and running on Heroku, because we mostly focus on, like, let's say, on the code and the thing to be deployed. So the idea is to start improving and moving the things along. So yeah, that's the one I mentioned. The thing is, like, we're mostly focused on quick and easy deployments. I mean, Heroku is pretty great; it works pretty great. But the thing is, like, it gives you like a less control on the infrastructure, and when you put something in scale, it's pretty expensive. So we want to not only tell the clients like, okay, we manage we can deploy your stuff, we can make your product alive, but also, like, meanwhile the process, we can save a lot of money during this. So that's one of the reasons. Well, again, we basically focus more in the code, but the truth is, like, we want to learn more and improve the process in the company. So, well, that's why also I mentioned Heroku previously. As I mentioned, Fargate provide less than Heroku, because you still need to be aware of, like, networking installation, VPC, subnets, NAT gateways, security groups, like how the services talk to each other or how they interact with the external connections. Load balancing, that's something that you don't see in Heroku. You just deploy your dyno and that's it. DNS records. By default, Heroku provides like a default DNS which you can use and start using your application. And and also the continuous deployment pipelines. I think Heroku, you can like set up like, okay, every time I push to master or something like that, I will deploy your stuff, and it worked pretty great. But these are the things that Fargate doesn't provide right away. You can achieve that, but you need to configure, or you need to have the knowledge of that. That's why Terraform could be very helpful, because Terraform, you can have everything in the declarative way. Everything is like you have a single source of truth where your colleagues can check on, and yeah, pretty much start like a discussion and how are you going to handle the whole infrastructure for that project. But the thing is, like, you still need to define every single component. I mean, Terraform doesn't give you like the knowledge of which cloud provider are you using, or how to like good practices and stuff. It's just basically a way to provision infrastructure to the cloud. So this give us like a considerable learning curve. So because as I mentioned before, yeah, Terraform is like not magic in terms of like the knowledge, or okay, I will deploy this right away. So that's one of the reason that we built a Terraform module for the company, and that we see that it could be very helpful to do this transition to the more like a managed solution, and more like we have more control on the prices and the prices and how the services interact each other. So the Fargate model I will show you in a little bit. Basically the aiming is to keep the same simplicity as with Heroku, but this is pretty hard, of course, because Heroku is like a monstrous service. But we're basically focused on the part of the computing. I mean, on the let's say the replicated dyno part, not the whole like let's say add-ons that you can add, like for example like databases or something like logs management, something like that. If you are just focusing on the computing part, well, because we will have bigger saving code, we have more. We will be more cost effective, and that will also, we can sell this to the clients and tell, okay, we're not using we're not using Heroku, which costs like I mean, like when in the scale will be like more expensive, and we go with this solution, and it's more benefit. And at the same time, we gain knowledge with of DevOps and AWS, so that's pretty great. And also we use less cloud providers, because it's very common that when you have like a compute starting a new project, you probably you're going to use an S3 bucket, or you're going to use some kind of like an email service. So at the end, we have like a Heroku, AWS, we have SendGrid, or many others. So it's great to cut one of those and focus on less cloud providers. So yeah. So this Terraform module basically deploys, of course, it needs to deploy the VPC, because without that, there's nothing. With two kind of subnets, one private and one public. The ACR repository, which basically the Docker registry for that AWS provides. The cluster itself and the task definitions. For those who don't know what a task definition is, basically like a pod, but on the ECS world, where there's many like containers together because of business or logic use cases. I don't know. Also, the application load balancer, because when you're deploying a Fargate cluster, every Fargate, let's say, task or node has it could have like a private a public IP address, but this is very ephemeral, because Fargate is intended only for stateless application. Because you cannot write, I mean, you can write to the disk, but you lose all the data. There's no way to manage volumes or anything like that. So that also means like the networking or the network interfaces are very ephemeral as well. So you need to some single point, which you can refer the whole, let's say, cluster. And also you have optional HTTPS for the deployment part. There you can use like a code pipeline in the module, which basically is like hearing, or let's say like hearing a new image to be that's being pushed to the ECR repository, and if there's a new image, it will start the whole code pipeline. I mean, like the deployment pipeline, which code build. And also by default, it has some logs group, which well, your application is like a printing some logs, and it will go directly to CloudWatch, and some basic CloudWatch metrics dashboard. So at the end, we have like trying to like replicate the same like the basic that Heroku provides by doing this in a simple Terraform module. So this is more or less what it looks like. I mean, this is the default configuration. There are optionals during the configuration for the module. For example, the NAT gateway at the beginning could be like very expensive and not necessary really, so you can remove it. But by default, this is what you get for the module. Also, the application load balancer could be like also a little bit pricey at the beginning, but when you compare like I mean, like for example, when you have two dynos, you are paying more or less like $50 only for the dynos, and for the same, like say, compute power with Fargate and even the application load balancer, you're paying a little bit less, like 40 or 35. So yeah. So this is what the module looks like. Well, of course, you need to like put the module sentence on it and give it a name, and the source is strv/fargate/AWS. And well, basically, this will be like the most, as I showed before in the diagram. This will like spawn a single service called API, which is exposing the 3000 port, is using 256 CPU units, 512 megabytes of memory, and is spawning 3 replicas. And if you might see, there's like there's like a label called task definition, and this is basically AWS like syntax for their task definition, which you need to define in a different file. And this, for example, this is API.json. This is like a how it's called, like it's a path that you need to have in your application, in your code. And basically here is the like the most basic one. We only have one container running there, and it's exposing the logs to the CloudWatch. So let's go to the demo. Wish me luck. Okay. Okay. So I have this. Can you see it? I think I should like zoom it a little bit. Yeah. So, yeah, this is the main file for Terraform. Since this is very basic, I'm just doing it in one file. It's okay. And well, one thing for those who follows like Terraform constantly, you will know that they just released a new. It's, well, let's say major version. It's not actually major because it's 0.12. But they release a lot of breaking changes and cool stuff with like dynamic resources and stuff. And yeah, this module is like supporting that version as well. So yeah, I'm using the provider of AWS, of course. And here's where the module is defined. It's pretty similar as the one I showed on the presentation, but with the difference that I don't want a NAT gateway because it's a demo. And also doing some stuff because of course the module is not to stop there. It's to like you can add more stuff on top of the module and some custom stuff. So in this scenario, I'm activating the, let's say, the load balancer to have a listener on HTTPS. So basically, I'm retrieving a wildcard certificate of my personal domain, and yeah, pretty much it. I mean, I create after that, creating a DNS record called GrillOps.Juan.dep, and yeah, is pretty much it. So let's deploy this. So first, let's do the planning. So yeah, it will plan quite a lot of stuff. I could go to the source code, but I think that will take a lot of time because there's a lot of stuff happening behind the scenes. You can see that to deploy this, I mean this thing with the Fargate mode, is going to create 56 resources, which I would say 30% of them is IAM resources because of course the services need to talk to each other and in a secure way. But you know, that's pretty boring thing for someone that has only been deploying stuff on Heroku and suddenly you say, okay, let's use this thing. It's like what? So it's better to like start doing the transition, doing something like defining like, okay, let's deploy a single service called API with 3 replicas and that's it. So okay, let's apply this. So the truth is, it will take approximately like 3 minutes, something like that. So I don't know if you have any question meanwhile this gets deployed. No question? Sorry? It's pretty easy because it's just like writing a standalone Terraform file. But the thing is like at the end, the Terraform people, the HashiCorp people, which is the owners of this tool, they provide, let's say, like a Docker hub, like for Terraform modules. So at the end, you have your whole Terraform modules. You need to create a GitHub repository that needs to be public, of course, and it has to contain some kind of like rules for the name. So this Terraform registry detected the repository, and basically they display the thing on their website. I can show you that because if we go to Terraform. Oh, they changed the page a little bit. No, it's here, Terraform module registry. So basically, if you go to Fargate, we look for Fargate. You can see many solutions, but this is one that the one that I'm showing you right now. And yeah, you can of course go to GitHub. And yeah, that's basically how it works. So, okay, I think most of the things are created right now. The thing that takes longer is the load balancer, I think. And yeah, I think if we go to my account, we can check how the things are spawning. For example, right now we have like the cluster with 0 services, but it's created. And you might be wondering, for example, here you can see that the name of that I'm giving to the module is called GrillOps, but you can see that it has a default on it before giving the proper name of the component, which is a cluster. So it's GrillOps default cluster, and this is because there's a cool feature in Terraform called workspaces, which is basically to replicate your same infrastructure between multiple, let's say, environments. So since I didn't provide a workspace here, it's just giving it the default workspace. But the idea of this is to have this single file and define, okay, I have a development workspace, I have a staging one and production one, and you have a single file and you can apply them separately. So at the end you have 3 environments which don't collide to each other. So yeah, we can also check, I don't know, yeah, VPC, why not? Yeah, there's a lot of stuff happening here. For example, you can see GrillOps default VPC. It creates the subnets of it. It creates, at least it creates two subnets. Sorry, I mean, at least create subnets spread between 2 ACs. But since I'm using US East 1, it has more than 2 ACs, so you can expose to, by default, it's exposed 3 ACs by default. And you can see that it has like 3 public subnets and 3 private subnets, which the services will be deployed here, and the application load balancer, of course, need to be on the public site because it needs to be reachable by the internet. Yeah, it has a lot of stuff happening here. Let's check. Okay, it's finishing, I guess. Yeah, I created the load balancer. It's creating the CloudWatch events. We can check also. Oh yeah, we can go to dashboard, and you can. I told you about like a basic metrics dashboard. So we can go there, and you can see like some basic stuff that you can provide for your services, like how many errors do you have, and the memory utilization, the CPU, and request response time. This is the most basic one. Of course, you can expand this, but this is what basically the model provides. So it has end. So okay, so I think the next step, I mean, if we go to the, oh, let's check the code pipeline. What? Yeah. So if we go to code pipeline, we will get a pipeline, of course, which has failed, and it's because there's no Docker container yet. There's no, I mean, Docker image on the registry yet, which is of course obvious. But let's change that by publishing one. So first I need to log to the registry, and yeah, of course I have already built the image that I have. Oh, I didn't show the application, sorry. Well, it's a very basic Node.js application, which I'm not proud of because it doesn't basically do nothing. But for example, is super cool because yeah, I'm requiring the OS module, which I'm using to get the host name of the Fargate service, so we can see how the thing is load balanced. That's basically what the application is doing. So yeah, that I already built the Docker image. So I'm just gonna push it to trigger the code pipeline. Okay. Okay, it's gonna take some time. But yeah, what else we can see? Let's get back a little bit to refresh. Yeah, I mean we can go to ALB to check the load balancers. Here you can see there's like an active load balancer. And when we see, of course, the target groups, there's no targets, there's no healthy targets because there's nothing yet. But you can have like an idea of how the everything is put together with this model. And the cool thing is like, well, when I'm explaining this to some colleague, is like a pretty basic, and and also they can like if they're curious enough, they can go to the source code and see what's happening behind the scenes. But to go to and having a running, let's say, a running cluster is pretty straightforward. So the push has finished. So let's check the code pipeline. It takes a little bit. There it is. So it detected a new push. So it's going to, of course, get in the theme for ECR. And there's like a code build, a small code build task. We can have a look on that. It's pretty straightforward. Let's go here. No, this is not what I wanna look. Is the I think it's this one. Yeah, here. You can see it's pretty basic. I'm basically like getting the new the input for the ECR and pushing the new image definition to the cluster. So this will of course trigger a new build to the ECS. A new creation for the task definition. So yeah, let's go to the pipeline again. So this is success stuff. But the thing is like since this is the first deployment, the cluster is already running services. You can see that if we go to the cluster, we already have 3 running tasks, and this is because the first task definition got defined, and it keeps like it's an orchestrator. So the scheduler is like, okay, when is this thing going to be ready to deploy? So since the very beginning that I pushed the the image to the ECR, the scheduler noticed that, and also it will start deploying the stuff. So that's why the first deployment is kind of like messy, because the thing is already running, but he will try to deploy a new version, which is the same one. But after the second one, it will work properly. But if this thing is running, that means if we go to GrillOps Juan.dep, we already have a running cluster. And if I refresh, you can see it's basically basic load balancing. Is changing the host name because it's a different Fargate service, and there are only 3 of them. Like only 3 of them. So it's going to deploy, which means that it will grow to seats, I guess. You can see that these are the 3 running, and it's going to provision 3 more. And after this thing is running properly, it's going to remove the last 3, but it's the same version. So I think that's it for the demo. Let me recap a little bit. I think that's it for the demo. So So yeah, you can start playing with it. This is the registry reference for the module. It's basically like it's already on the Terraform registry. It's compatible with the last version of, let's say, the last minor version of Terraform. They don't release a major yet. Of course, it's under development. There's more stuff on our minds, such as like, also it's using our projects. But yeah, as I told you, like it's under development. There are more things on the roadmap, which are like I call it like development mode, which no load balancer, but it's pretty hard to do it because as I mentioned before, the Fargate services are very ephemeral, even for the for their network interfaces and their volumes. So it's very hard to keep a single IP address and reference that. So far, we cannot use like external Docker image. I mean, like something different than the ECR, something that we have on mind, and also any bug that comes along. So here are some reference. Probably this presentation is going to be available. I don't know. And yeah, that's it. Thank you.